Alright, so we want to take the derivative of this, and well, I don't know about color coding, bruh, but it's like dx of sine. So this is like number 4, right? So number 4 sine of x to the power sine of x to the power sine of x. Okay, so there's at least one other video on YouTube showing you how to do this, but the path I'm going to take is different. So like a different offering, yeah? Okay. So what we're going to do is this, right? We're going to be like, okay, so this is y. So how do we do this? I don't want to rewrite it. So you see that what we want to do is take the derivative, right? So I'll just erase this and be like, okay, so I don't need the parentheses anymore, it looks like. So we go y equals, and actually need the space, right? So y equals, so y equals, and next we take the natural log. Take the natural log, and I write natural log, right? So what that means is, now using the log exponent rule, I could put this right there, right? Okay, so from what I just said, it means I could get rid of this and write sine x to the power sine x right there, right? Now notice we have a product between sine to the sine and the natural log of sine here on the right side, right? Okay. So here we are. So once again we have sine, like a fancy function, right? Compared to like polynomials. We have sine, an exotic function stuck in the exponent. We don't like that, right? So we want it to, like be in a product, something like that, right? So we're going to take the natural log once more. So what we'll have is natural log of natural log. So I'm taking the natural log on both sides. On the left, we have natural log of y. And then on the right, we'll have, see, this is why I don't like color coding, but maybe it's helpful. On the right, we'll have the natural log of, right, this whole thing, right? So the natural log of sine of x to the power sine of x times the natural log of sine of x. Yeah. Right? Okay. Now we use the product log rule, because we have log of something times something. And remember, what we could do there is split it into a sum of the natural log of both of the things that are in the product, right? So what I'm saying is, now we could write, and the parenthesis right here, and then be like, plus, right? And then it's going to be the natural log of the natural log of sine x. Right? Okay. Now we are ready to differentiate, and I'm going to abandon the color coding. It's not working out, right? Okay. So we're going to differentiate. On the left, I'm going to have the derivative of the natural log of y is first 1 over the natural log of y But then chain rule says I should multiply by the derivative of the natural log of y, which is 1 over y. But chain rule once more says now I need to multiply by the derivative of y, which is dy dx. Right? Okay. On the right hand, right, first, we can once again use the log power rule in this part, right? So that means I could get rid of this. It's going to be like sine x right here. Alright? So then now, in differentiating this right-hand side, remember we've already differentiated the left side. In differentiating this right-hand side, I have to keep product rule in mind here and chain rule in mind right there, right? So product rule here says I've got f times g. F is sine x, and then g is ln of sine x. So f prime cos x times the natural log of sine x, this is f prime g, plus f, which is sine x, times the derivative of g prime, that's 1 over sine x, and then by chain rule times cos x, right? So we just got done applying the product rule here, but we still have to do chain rule over there, right? So plus 1 over the natural. Apparently, like even love hates on me, and my GoPro too, because like all of a sudden, right? I swear on Christ, like the video just stops while I was recording and I was in this part, right? So like it says that it's got an SD card error, but like the GoPro is charged enough. It had like 91% battery, like. And I've used these SD cards. Lucky for me, I have more than one. So like we're continuing on another SD card. But yeah, like okay. So anyway, what we did is we were done with applying the product rule here to get the derivative of the right hand side a little bit done, right? And that's up to here. And then I was on to this part, and so I took the derivative of this here. Well, I started. The derivative of this here is, well, since it's a natural log of the natural log of sine x, it's 1 over the natural log of sine x, but by chain rule, we got to differentiate the natural log of sine x, and that's 1 over sine x, and then chain rule once more, it says cos x, right? Now, cos x over sine x is cot x, so we can write this at the end is cot x, right? Furthermore, we've got some simplifying to do here, right? Like that. Okay. And additionally, notice that this is a product. So like I could get rid of 1 over y here, put a times here, and put a y here, right? But then by applying the log power rule, I could put this y as an exponent, right? So that's what I'm going to do. So it would be like y is right there, right? So now, since what we're after is a derivative, what we're after is dy dx. And to realize dy dx, all I have to do is multiply both sides by this quantity right here. So I'm going to put a giant parenthesis here, and here, right? And get rid of this here, in the denominator, which is the natural log of y to the y, and put it right here, the natural log of y to the y power. Okay, obviously we can clean this up a little bit, but that's all that we have left to do. So then we see that the derivative of dy dx, I'll write it right here, right? I'll write dy dx is equal to, I think we have enough space to fit in there because it simplifies pretty nicely, right? So it's going to be cos x times the natural log of sine x. And then plus cos x, right? Plus cos x. That's all that survives right there, right? Yeah. And then plus cot x over the natural log of sine x. And all of this is multiplied by the natural log of y to the y, which is the natural log of, remember what y was. Y was equal to sine to the sine to the sine. So the natural log of y to the y would be like ridiculous. It'd be like sine x to the sine x to the sine x all this to the sine x, to the sine x, to the sine x. Boy. Yeah? Okay, cool. So, yeah, that's about it. And, right. Okay. I hope you enjoyed this, and yeah, have a great day. I hope Christ my love is with you. Yeah? Okay, cool.